In this video, we examine the energy level diagram of a rigid rotor and look at rotational transitions and their selection rule. For a rigid rotor, the energies of the stationary states are given by Ej equals B times J times J plus 1. B is a rotational constant. B equals h bar squared over 2I, with the moment of inertia I equal to the reduced mass mu times the distance r squared. The rotational constant is most commonly given in terms of wave numbers. For that, it is denoted B tilde, and it's equal to B divided by hc. The rigid rotor has two quantum numbers, J, which is equal to 0, 1, 2, and so on, and M, which can be 0, plus minus 1, and so on, all the way up to plus minus J. The energy clearly depends only on J, so all states with identical J but different M are degenerate. The number of degenerate states for a given J is Gj, equals to 2J plus 1. Let's plot the energy level diagram. This is the energy. It starts at 0. For J equals 0, we get one level at the energy of 0. For J equals 1, we get 3 levels at the energy of 2B. For J equals 2, we get the energy of 6B, and we get a total of 5 levels. For J equals 3, we get an energy of 12B, and we get a total of 7 levels. These 7 levels have M values from -3 up to +3. As you can see, this gets quickly out of hand with increasing J. An alternative is to just draw one line for each group of degenerate states. And indicate degeneracy on the side. For a photon to be absorbed and induce a transition between two states, it must fulfill the rotational selection rule. Let's look at a transition from Jm to another state with J prime and M prime. The selection rule comes in 3 parts. First, the photon energy has to match the energy gap. So E photon equals delta E, that is E of J prime minus E of J. Second, the rotor must have a non-zero electric dipole moment. This is true, for example, for HCl or carbon monoxide. However, nitrogen or hydrogen gas do not have an electric dipole moment, so they cannot undergo pure rotational transitions. Third, transitions can only occur between states of adjacent energy levels. So J prime minus J, which also denoted as delta J, has to be equal to plus minus 1. In addition, the change in the quantum number M has to be 0. M prime minus M equals delta M equals 0. This holds only if the electric field component of the incident light is parallel to the z direction. Transitions that fulfill these 3 conditions are called allowed conditions. Conditions 2 and condition 3 stem from the requirement that the transition dipole moment has to be non-zero. Now let's compute the transition energy for going from J to J plus 1. Delta Ej equals E of j plus 1 minus E of j, which equals, according to the energy expression, B times j plus 1 times j plus 2 minus B times j plus 1, which simplifies to B times 2 times j plus 1. Whenever a photon matches this energy for any j, it is absorbed. For diatomic molecules, typical values for B tilde, which relates to B via B tilde equals B over hc, the values for B tilde are in the range of 0.1 to 60 inverse centimeters, where the 60 inverse centimeters is for dihydrogen. Therefore, rotational transitions occur in the far infrared. Everything so far applied to a rigid rotor, which is only an approximation for describing the rotational behavior of a diatomic molecule. However, in reality, diatomics are non-rigid rotors. The faster a diatomic rotates, the more the bond is stretched due to centrifugal forces. This can be taken into account by an extra term in the energy expression. It is Ej equals B times j plus 1, as before, minus D times j squared times j plus 1 squared. The second term, including the minus, is the term describing the centrifugal distortion. And D is called the centrifugal distortion constant. The negative sign means that the energies in a non-rigid rotor shift a bit lower compared to the rigid rotor. The larger J, the larger this downshift. In summary, we have looked at the energy level diagram of a rigid rotor and seen that there is high degeneracy. Transitions are only allowed between adjacent levels, delta J equals plus minus 1, and require non-zero electric dipole moment. Finally, for non-rigid rotors, there is an additional centrifugal distortion term.